right, so tonight we have Wednesday night's homework. You need to make sure that you have numbered these, starting with 10, 11, 12, 13, 14, 15, 16, 17, and 18, just to make it easier for when you plug in your answers for, let's see if we made that a little clear. Okay, plug in your answers on Edulastic. Okay, just like yesterday, I'm not going to do the first two with you because you should be able to plug those straight into the calculator. But looking at number 12, it says a cookie recipe states that for every 3 cups of flour, 1.5 teaspoons of vanilla are needed. How many teaspoons are needed for 5 cups of flour? And since we're comparing two different things, we're going to end up doing a ratio box. So we're going to draw a ratio box. And we're comparing cups of flour, to tablespoons of vanilla. So I've got flour to vanilla. My first column is my original ratio 1. And it tells me that if I have 3 cups of flour, I need 1.5 cups of vanilla. Or teaspoons of vanilla, my bad. The question says, how many teaspoons would you need if you had 5 cups of flour? So we're looking for the vanilla. So to solve this, we're going to have to cross multiply 5 times 1.5, and then we're going to have to divide it by 3. So when you plug that into your calculator, you should get your answer for how many teaspoons of vanilla we need for 5 cups. All right, remember to make sure you circle your answer so it's easy to find. Number 13 says, how many ounces are there in 13.5 pounds? So we're looking for how many ounces are in 13.5 pounds. Well, we know that there are 16 ounces in 1 pound. Let's see if I can spell it correctly. And so if we set it up this way, it kind of creates a ratio box in a way, where we're looking for this box right here. So we can cross multiply 16 ounces times 13.5 pounds, and then divide it by 1, and it's going to tell me how many ounces are in 13.5 pounds once I put that in my calculator. So I would do 16 times 13.5 divided by 1. Number 14 says Tatiana reads 40 pages of her book every night for X number of nights. Write an expression that represents the number of pages she has read. So if she reads 40 pages every night, that means each night she's reading 40 pages, and it takes her X amount of time to read those. We want to figure out how long it takes her, then we're going to have to multiply 40 times X, which can also be written as 40X. So just to test it out, for example, if she read 10 minutes every night, okay? Let's say, let me read that. Tatiana reads 40 pages of her book every night for X number of nights. All right, so X represents the number of nights. So let's say she reads 40 pages for 5 nights. Then I would have to do 40 times 5, which would give me 200. Okay, so this does work. This is our answer. This is our expression for number 14. Number 15 says Jonathan ran 5 days this week. The most he ran in one day was 3.5 miles. Write an inequality that shows the distance Jonathan could have ran any day this week. So if at most he ran 3.5 miles, that means he can't run more than, but he could run 3.5. So he could run exactly 3.5. Jonathan could run exactly 3.5, or he could run less than 3.5. So when we put those together, it would be Jonathan can run less than or equal to 3.5 miles. So this would be our inequality for number 15. Number 16 says every day Lewis buys 5 more baseball cards to add to his collection. If he already had 25 baseball cards before making any purchases, how many will he have on day 20? So, if Jonathan had 25 cards that he started with, and then each day he adds 5 cards. So, 5 cards each day. So, 5 times D. Okay. If by the time he is on day 20, how many cards does he have? So if I have 25 times 20, okay, we could plug this in. This 20 represents day 20. I would plug this in. It would give me my answer of how many cards he has now. Because he started with 25. We can't forget that he started with 25. All right, number 17 says find the area of this triangle. We got 7 as our base, 8 as our height. The area of a triangle equals 1/2 base times height. So I would take half. The base is this bottom piece right here, which is 7, times the height, which is 8. And I would plug that in, and that would give me the area of my triangle. And number 18 says Kevin is going to purchase sod for his backyard. How many square feet of sod will Kevin need? So he's kind of got this L-shaped looking piece of lot here. Okay, and if I split it into pieces that I know, I could split it like this. Okay, now I have a rectangle here that is 10 by 25 that I need to find the area of. And then I have this rectangle right here. But I cut this rectangle. This whole piece used to be 30, but I cut it. I know that opposite sides are congruent, so I know that this side is 10, that means this side is 10. So I've used 10 of the 30, which means this piece from here to here has to equal 20. So I need to find the area of this rectangle right here. So I would do length times width, and I would need to add those two pieces together to find my total area. And that's it.